So let's take a look here. So they're asking us to find the voltage V of X. So V of X is right there. And this looks kind of complicated, doesn't it? But fret not, we'll figure it out together. So do you remember how we said that voltage along a wire is the same until it hits an element? Well, if we were to look at this wire right here, that voltage is the same as that point right there. What we can do is, in this course, is we can take the wire that has the same voltage, has no elements on it, it's just a wire, and we can squish it down into one point. We basically take that wire and ball it up. And when we do that, we're going to make a new circuit that looks like this that we can work with. It's a lot easier to visualize it. So I'll draw it very quickly. Okay. And this point here, oh, let's see, that point is the same as all that right there. So that's all we did was take that point and squish it down into one spot. Okay. So this is still V of X up here. This is 4. This is 4. This is 10. This is 10, and this is 1. And this is 10 volts over here. Okay, so we can see that if we want to find V of X, what we need to do is we can figure out by a couple things, but probably the easiest way for us is if we know the resistance value, we can say that if we know the current that comes up through it, then we can just do V is equal to IR. So let's go ahead and see what that process looks like. So we're going to do this in a two-step. So this will be parallel 1. We see these two are in parallel. And this will be in parallel 2. So parallel 1, I'll call that R parallel 1, will be 4 times 4 over 4 plus 4. 16 over 8 will give me 2. And then if we did R parallel 2, it would be 10 times 10 over 10 plus 10. And that should give me 100 over 25. Okay. So if we were to draw it again, real fast, it's 1, 5, 2, and then 2. Okay, and then we're going to maintain that that point right there is still that meatball that we had. Okay, and then this is still 10 volts, of course. All right, so now let's see what we can do. We can do a couple things. We can either say we can do a KVL on it to figure out what the voltage is across that resistor, and we say that that voltage across this resistor here is going to be the same voltage that's across that point. And these two branches here, or these two resistors, are in parallel with each other. So if we combine them down and then split them back up, they should still have the same voltage across them. So if we went the KVL route, let's see what that looks like for us. We'll do the -10 And all these have plus minus, by the way. So plus minus, plus minus, plus minus. So if we do plus, and there's one uniform current running through here, so do it like that. I'll just call that IS. Why not? So voltage across the 2 plus the voltage across the 2 plus the voltage across the 5 plus voltage across the 1 will equal 0. And if we go and replace it with V is equal to IR, it will be IS R of 2 plus I of S R of 2 plus I of S V of 5, or, oh, not V. Should be R5 plus I of S R1 will be equal to 0. But let's look at this. What do we know? What do we don't know? So we know all these resistor values. We know this V of S. We just don't know the current. But can we find the current? Absolutely. All we need to do is I of S is equal to 10 divided by R of 2 plus R2 plus R5 plus R1. And that should give us 10 over 2 plus 2 plus 5 plus 1. And that gives us 1 amp for I of S. Okay, so now we know what I of S is. I of S is equal to 1 amp. And we know that 1 amp is going to run through that 2 ohm resistor right there. So we can say the V of 2 is equal to I of S R2. That'll be equal to 1 amp times 2 ohms, which will give us 4. Oh, wow. That is not the correct math. 2 volts. V of 2. Okay. So if we had this, where I of 1's coming in, and this was the resistor 2, and that resistor 2 is just made up of a 4 and a 4, and here, I'll use blue, why not? And we're looking at this point and that point, and this point and that point. The voltage difference across this one is the same as right there. So it's the same across both 4 ohm resistors. So that means that here, let me, that. So across here will be 2 volts across both of those resistors. And this is where our V of X is. So our V of X is going to be equal to 2 volts. All right. Does anyone have any questions about this particular question? All right. Well, then let me pose a question real quick. Could you do it a different way? Okay. Which part is the last part that you'd like me to repeat? Is it the part about the voltage being split up is the same across both branches? Okay, yeah, sure. So the question was here, how do we know that the voltage from this resistor, the voltage across it, which was that 2 volts, is the same for both of these? So if I put my 2 big meatballs here, and I say that the voltage difference across from here to there is the same because they're all in that same wire, then down here, I'm just transferring it down and saying, okay, well, if I was to combine these two resistors into that one resistor, that blue and green point don't change. That's still the same node. They still have the same voltage. So if I was to go back and forth between those two, the blue and green points don't change and they keep the same value. So that means that if I have some voltage like, I don't know, V of A on this side, and I had a voltage V of B over here, that means that even if I was to combine these down, I'd still have V of B over here and V of A over there. So it's still the same voltage difference across different branches, which gives you the same value. Does that help clear some of that up? Okay, looks like there's another question. So if the 2 ohm at the top left was a 3, for example, then V of X would be equal to 3. Oh, which 2 ohm resistor are you talking about? Are you talking about that one there? Okay, not necessarily. Because, okay, so the question is that would the voltage V of X be equal to 3? Not quite, because okay, I'm gonna write it down here for you. Okay, so if first R2 was R3 instead, so if we were to do it like that, your I of S would be equal to 10 over 3 plus 2 plus 5 plus 1, which would be 10 over 11, which I think is like 0.909 or something repeating. Yeah, so 0.909. Okay, so this is, what that does is that changes the source current. And now when I go and find V of 2, V of 2 will be equal to 0.909 amps times 2 ohms, which would give me 1.818 volts, and V of X would be equal to 1.818 volts. So when you change one of those resistors, what you're doing is you're changing the current throughout the circuit. And I want you to notice something. So we bumped up one of those resistor values to a higher value, and the current went down in the circuit. So that implies that the more resistance in a circuit, the harder it is for that current to get through it. Does that help clarify some of that? Oh no. If things were only that easy. But all right. Do we have any Any other questions about this one? No? All right, let's move on to the last question for tonight. Thank you for sticking around, and hopefully we'll be able to finish at a